right, this is section 3.3 continued. We're just going to talk about comparing slopes briefly here. I mentioned that lines have increasing or decreasing slopes, and the indicator of increasing has a positive slope and decreasing has a negative slope. However, we want to sometimes make comparisons between slopes that are increasing or slopes that are decreasing. We're just going to talk about ones that have an increasing slope right now because that's more applicable to most of our real world models, most I say. So this means that when we're comparing this the steepness of a line, we're talking about it having greater slope. And so you see here we have steepness of lines. You have this one which has a slope of 1/3, we'll say, and this one that has approximately a slope of 1 over 1, this one that has a slope of 3/2, and this one here that's getting really close to being a vertical line that has a slope maybe of 7/2. And as these get up closer to being undefined, you see they're having a steeper and steeper slope. That means that they're having a greater positive slope. This means that their vertical change is larger than their horizontal change. So you see this one is small compared to big down here, even, and then bigger compared to smaller, way bigger compared to smaller here, and that's what we're looking at. So we're going to just discuss these positive slopes at this point, and we'll see that the larger the vertical change to the horizontal change, the steeper the line. So let's do an exercise from Lehman's book. Let's look at the exercise on page 140. And so let me see if I can bring that up here. There it is. All right, and we're going to look at this. This is going to take up most of our space here, so I'll have to switch back and forth. It says, while taking off, airplane A climbs steadily at 4,800 feet over a horizontal distance of 9,000 feet. So we're saying that this plane A is going to change of 4,000 feet, 4,800 feet up this way as it goes 9,000 feet this way. In other words, we're talking about our vertical change, our y change, over our x change. And I'm just going to use that abbreviated method of saying that. So we have a 4,800 to 9,000 for that A. And we know we can cancel those out, right? And those are both even, so I can take out a 2, so that gives me a 24, and that gives me a 45, and those both have a 3 in common, so that further is going to come down to an 8 there and a 15 there, and that's where it's going to end. Now we talk about plane B as well. In plane B, it says it's going to steadily climb at 5,800 feet over, now I'm going to have to switch back to find out what our horizontal is, over a horizontal distance of 10,500 feet. So 10,500 feet in our horizontal direction. And so plane B, this is our vertical, which is 5,800, and it's over our horizontal of 10,500. And again, we can simplify this. We'll take out that factor of 100, and then 105, that's divisible by 5, so that would go in there 21 times, which is only divisible by 7 and 2. And let's see, this is not divisible by 7 and 3, and this is not divisible by 3 either. So we're at a 58 to 105. And so what we're looking at is which one has the greater incline, and we want to explain. So for every 8 units here, we go up 15. For every 58 here, we go up 105. Now that's a little hard for us to think about. So if we take this to a unit ratio, we're looking at 8 divided by 15, which is a 0.53333, and so on and so forth here, as compared to 58 divided by 105 here, which is a 0.55238, so on and so forth here. There's a repeat. And so this one is